Hello guys, welcome to my YouTube channel. So today we shall discuss something about horizontal alignment. This is the first part of lecture series that I am going to conduct to YouTube. So those who are interested can be benefited with that, right? So before starting anything before starting anything of the design, we have to have a thorough understanding of the theories behind. So that is exactly what I am going to do today. So today I am going to discuss about horizontal alignment, and later we'll discuss vertical alignment and the theory stuff that is related to highway design. So, horizontal alignment is defined as a series of straights and circular curves connected by transition curves indicating the path of the road in plan. So, you have to understand that a horizontal alignment is a combination of straights and circular curves. Okay, so there it says connected by transition curves, but you have to understand the transition curves are usually used in this country for expressways. Why? Because what are our speed limits are 70 kmph in rural areas and 50 kmph in urban areas. Now the thing is, a spiral curve, why do we employ a spiral curve? Because we believe that the driver cannot take his own transition curve within the constraint of the lane width. Therefore we provide one ourselves. Now, if the driver is able to take his own transition path, now because I think most of you have driving licenses, so when we are going to enter a curve from a straight, usually we take a transition path. We suddenly don't go to the end of the straight and then jump into the curve. We take a transition curve. So that transition, okay, that transition should be able to be taken within the constraint of the lane width. Otherwise, what happens is you are encroaching the opposite lane, right? Therefore, we employ a transition curve. But here, according to the research and according to the theories, for the speeds lesser than 80 kmph, of course, a driver can take that transition path within the constraints of the lane width without providing a transition curve. Therefore, we provide transition curves because transition curves are costly and it is difficult to construct. Therefore, we provide transition curves only for the highways that are designed for greater speeds like 100, 110, 120 like. So in our country, the expressways are designed for 100, 110 and 120 depending on the expressway. Therefore, we provide transition curves only for the expressways. For the national highways, we usually don't provide. Okay, so that is what they are telling in the second line. The tangents may directly be connected where a transition curve could be omitted. Okay, yeah. If you don't want to have a transition curve, a tangent can be directly connected to a curve without having a transition curve. So these are the major considerations of our highway design or the horizontal alignment. Number one is safety, that you know. Okay, safety first, right? Now, safety first in the sense, a road should be safe. So you can have a very costly road, but if it is not safe, if there are so many black spots, that is of no use. So one of the major considerations of a highway is safety. Then the profile. Profile is how you are going to design the vertical alignment, because you have to go there and check the site whether it is possible to have a reasonable profile in the road. Then the type of facility, if it can be either A class road, B class road, or C class road, or an expressway, or whatever. So depending on the facility, we have to decide what are the curve radii and everything. And then the design speed, because we have to provide larger curve radii for larger design speeds. If the design speed is less, so have you seen that Hatton road where design speed is somewhere like 30 kmph? So the curve radii can be narrow. And then we have to think about geotechnical features. So the soil properties, whether soil can whether we have to strengthen the soil, or whether we have to we have to provide retaining walls, or if a filling is required, something like that. Then the topography, whether it is like going along a river or a water path, or whether there are mountains and things like. Then the right of way cost, so you can have a very nice and excellent road, but if the right of way cost is very high, and your whole effort is useless. And then of course we have to consider the construction cost as well, right? So we'll go to curve design. There's a small theory considered here. Movement of a vehicle along a circular path. When a vehicle is moving on a curved path, it is subject to an outward force. So everybody knows, when an object is moving on a curved path, it is subject to an outward force, commonly known as centrifugal force, right? So if there was no centrifugal force, of course, the Earth cannot revolve around Sun. Why? Why? If there was no centrifugal force, what will happen? Due to the gravity of the Sun, our Earth will fall into Sun. Okay, like that. Anywhere in the non-universe, if a vehicle is moving on a curved vehicle or an object is moving on a curved path, it is subject to an outward force, commonly known as the centrifugal force. So what we are doing is, in order to resist this force, it is a usual practice to super elevate the roadway cross section. That means we tilt the road into the other direction. So just think that you are standing there. If the centrifugal force is acting towards the right hand side of you, so we tilt the rod into the right hand side, right? Then if the centrifugal force works to your LHS side or the left hand side, then we tilt the rod into LHS. So for a given radius and a speed, a set force is required to maintain the vehicle on the circular path, that you know, right? F equals mv squared over r. So following factors are assumed to contribute to this phenomenon. So what are they? So here, this is an equation derived using this simple theory. Okay, movement of a vehicle along a circular path. So side friction developed between tire and pavement, that is this F. Usually we denote it by mu, but in highway engineering we denote the friction factor by simple F. And the super elevation. Super elevation is E. That is a percentage value, how much it is being tilted, right? So we'll discuss about side friction factor. The side friction, or the value of the coefficient of lateral friction, depends upon a number of factors, among the following are dominant. So the side friction factor depends on following three parameters. One is vehicle speed, that is obvious, right? mv squared over r. Type and condition of the roadway surface, because the mu or f depends on type and condition of the roadway surface. And then the type and condition of the tires, because that also affects to the friction factor. And one thing you have to see is these side friction factors are being derived through research, and depending on design speed, for bituminous roads and gravel roads there are different friction factors. So if you take 70 kmph, for a bituminous road your side friction factor is 0.15, and a gravel road it is 0.1. So we'll discuss about type of curves. The type of curves used for horizontal geometry are as follows: simple circular curves, compound curves, reverse curves, similar curves, and transition curves. Okay. So this is simple curve. There is a one straight here, another straight here. There is a curve in between, so that is called a simple curve. This is a reverse curve. There is one curve to clockwise direction and the other curve to anti-clockwise direction. So it is called a reverse curve. And then compound curve is both curves are turning into the same direction. So spiral means this radius is changing. Right, we'll go to design of horizontal alignment. So these are general considerations. Alignment should be maintained as directional as feasible. So that means, so if you are going from A to B, say this is A, this is B, so you should not go like this. Okay, so it should be directional as much as possible. The topography of the region should be considered when designing the alignment. Okay, so you have to consider about the mountains, the water paths and everything, because it is not very nice to go and have a tunnel here. Okay, because if the tunnel is inevitable, of course you have to, otherwise we need not to have a tunnel. The alignment should generally conform to the natural contours of the area, otherwise it is very ugly. It is rising and falling like roller coaster. So just think that here in this road it conforms to the natural contours of the area. It is generally the accepted practice to keep the number of curves to a minimum. So higher the curves that you have, uh, more difficult it becomes for the driver to drive. Okay. Then sudden turns like like hairpin bends. Okay, should be avoided as much as possible. Then these are some considerations. A curve at the end of a long tangent should be large enough to ensure safe driving. Okay, that means you should not have a long straight and at the end of it you shouldn't have a hairpin bend. That is very dangerous. So the vehicle will slip out of the road. And a radius as large as possible with respect to particular design speed should be adapted. So if you are going to design, say, just think that if your design speed is 70 kmph, usually even 225 meter radius is enough. But if you can provide, say, 1000 meter radius, provide that. But don't go for the curves beyond 5000 meters. So these are usually we do not use. Instead we can have a direct connection between the two tangents without a curve. Okay, so minimum radii should be restricted only for the critical location. So if you are going to provide 225 or say 205 depending on your speed, they should be kept only for the critical locations, not everywhere. Okay, and then in the places where the use of reverse curves become unavoidable in hilly terrain, adequate long transitional curves should be provided for super elevation runoff. So that means what they are telling is we should not provide reverse curves. Instead, in between two curves, we have to have a transition curve. These are some of the things that are not practically possible, right? So we'll go to simple circular curves. So this is a simple circular curve. Okay, so this is the terminology. So this is called back tangent, forward tangent, and this is the length of the curve, right? This is mid ordinate, and this is subtangent 1, subtangent 2. This is the point of intersection, like, right? Simple circular curves are just plain circular curves whose design will be governed by following factors: minimum radius of curve for super elevation development requirement. Other one is minimum length of curve. So the minimum curve radius is designed with the following objectives in view. So these are the things that we consider when we design a simple circular curve. The design speed of the curve should represent the speed below which most of the drivers operate. So that means if there is a road that now for the time being, if the drivers are traveling at 60 kmph, don't go and design it for 30 kmph. So it's not going to work. That is why they are telling it should be the speed that most of the drivers are operating. The tendency of slow moving vehicles to track towards the center. Okay, so if you are going to have a very narrow curve and if your super elevation is very high, so these slow moving vehicles will come to the center. Then stability of high large commercial vehicles. If your super elevation is very high, so it can topple. But I have never heard such a thing happen. But theoretically possible. Length available to introduce the necessary super elevation. A curve should be long enough to introduce super elevation. If the curve is very small, in the sense very short, so you cannot provide enough super elevation development. And then they have provided this table depending on the design speed and depending on the super elevation. So you have the minimum radii. Now as an example, if your design speed is 70, if you are proposing to provide 2.5 super elevation, you have to provide minimum 225. If your design speed is 50 and if you are if according to the topography only you can provide 95 meter radius, your super elevation has to be 4%. That is how you are going to read this table. And the adverse crossfall means sometimes centrifugal force is F equals mv squared over r. Now what happens when the r increases? When the r increases, what happens is that centrifugal force is going to be small, right? So then even with normal crossfall you can because only with the friction you can uh, control the centrifugal force. So this adverse crossfall means that if your design speed is 70, if you can provide a curve greater than 100,000 of course you don't want to have a superelevation at all. Okay. So these are transition curves. This is a railway. Now you know this curve radii changes. Okay, from here to here. So just think that this is 100 and this is 500. So the transition curve changes its radius from 100 to 500. Okay, any motor vehicle follows a transition path as it enters or leaves a circular horizontal curve that you know, like drivers, right? The steering change and the consequent gain or loss of centrifugal force cannot be affected instantly. For most curves, the average driver can effect a suitable transition path within the limits of normal lane width. That is why. So if your design speed is lesser than 80, most of the drivers can effect a suitable transition path within the constraints of the normal lane width. So you don't want to have another transition curve. That is why we don't employ. Then with combinations of high speed and sharp curvature, the resultant longer transition can result in crowding and sometimes actual occupation of adjoining lanes. That is the problem. So if you have not provided the transition curve, sometimes there can be crowding and actual occupation of the adjoining lanes. So that is very risky. In such instances, transition curves would be appropriate because they make it easier for a driver to confine the vehicle to his or her own lane, because instead of letting the driver to take his own transition curve, we are providing one for ourselves, right? Then it is easy for the driver to take that. The employment of transition curves between tangents and sharp circular curves and between circular curves of substantially different radii warrants consideration. So you can provide transition curves between tangents and sharp circular curves, or circular curves of substantially different radii. Say one you are having something like 100 and other one is 1000. So you can have a, transition curve in between. So this is a compound curve. A compound curve is a series of two or more single curves that run in the same direction and join in a common tangent point here. So this one in this direction, that is clockwise direction. This one is also clockwise direction, and they are joined in one particular point. Here also same. Then compound curves, you can see in the places where the topography of the portion of an existing contour such as bridge or level crossing does not permit to use a single curve, a simple circular curve with two radii may be adapted. Now the thing is this, now just think that you have to cut this point because there is a bridge. So you cannot have a simple curve like this. Instead, so here what you have done is you have got two compound curves. As a general rule, compound curves are avoided wherever possible and the single curves are used instead. So that is a good practice. Okay, this is some theory part, but of course that is not practical. In case the necessity of compound curve is inevitable, the radius of the flatter curve should not be more than 50% greater than the radius of the sharper curve. That means if you are going to have say your first curve as 100 meter, uh, then the next curve should not be greater than 150, but these are not practically possible. Nevertheless, the use of compound curves provides the designer with a flexible tool to better fit the highway to the terrain and other ground controls. Then we'll discuss about reverse curves. Now reverse curves, you know, it is here curve runs here anti-clockwise direction, here clockwise direction. So they are joined in one particular point, a common tangent point. So that is called a reverse curve. A reverse curve is a curve of opposite direction with common or near common tangent points. So accounting for the difficulty in altering the superelevation direction, reverse curves with common tangent points should be avoided as much as possible. So the best thing is to have simple curves and straights. But of course when it comes to rehabilitation projects and depending on the topography and things for the new roads, sometimes we will have to use compound curves and reverse curves. That is what we have to understand. So, yet the reverse curves are unavoidable under following conditions. What are they? If the planned transitions are used, if the curve radius is greater than the radius for which transition is not required, where circular curves are used without transition, the true reverse curve arrangement should be avoided by separating the tangent points by a distance so that a super elevation development could be suitably achieved. Okay, so that means just don't have a common tangent point, instead have a straight in between to give the super elevation runoff. So similar curves. It should be noted that the similar curves linked by short tangents are undesirable on the ground of both appearance and safety. So that is, there are two similar curves and they are joined by a small straight in between. Okay, so the maximum length of the short tangent is selected so as to not to have much visual or practical effect, and the minimum length of long tangent is selected so as to give visual and practical separation of two curves. So these have to come through the experience. Okay, these are some of the theories. Then we'll discuss a little bit about widening of carriageway on curves. Have you seen them? Sometimes there is a curve and there is a curve widening there. Especially in expressways, we have to definitely provide the curve widening, otherwise it is risky. So carriageways need to be widened on some curves because a vehicle passing through a curve occupies a greater width of the road compared to its motion on a straight. That is understood, right? When you are going to take a curve, it occupies a more width compared with that in a straight. Curves are widened to avoid difficulty in steering the vehicle in the center of the lane. The amount of widening required depends on radius of the curve, vehicle length and width, width of lane on straight, lateral clearance between two vehicles. Okay, right. So that is all for today regarding highway horizontal alignment. So the next day we will discuss about side distance. Thank you very much.